Everyone. In this video, I'm going to run through your virtual lab, the case of the 5-droppers. So this is a precipitate lab. We're actually planning on running one of these this upcoming week, so it kind of works out that we have this option online. So a precipitate lab is basically when you take a bunch of solutions and you mix them all together in every possible combination. Not all at once, but let's say you have 5 solutions, you'll mix, number 1 with number 2, number 1 with number 3, number 1 with number 4, and eventually you do that until all the combinations are done. And you see which ones react and which ones don't. So in this virtual lab, you're going to not just perform a sample precipitate lab, you're going to actually gather data that's going to be used to answer this question, this mystery of the case of the 5-droppers. So I'll quickly run through what you're going to turn in for this. So first, it's a picture of your results with both grids filled in and your droppers identified. And it's going to be a document on which you write or type the total and net ionic equations for 3 of the reactions that go through. So you'll see a lot of reactions go through. You're just going to pick 3 of them and write the total ionic equation and the net ionic equation. And there will be separate sections in Google Classroom that you're going to put these in. So make sure you pay attention to that and you put the picture in one and your document in the other. So how do we actually do this? Well, all you got to do is Google case. And the first hit should be it. And this brings you to this website to the 90s, but it's really straight out of 2003. So it's definitely old, but it works great. So in this, on the left here is the lab setup. So you have 5 droppers, which are labeled barium nitrate, potassium iodide, potassium carbonate, lead 2 nitrate, and nitric acid. And on the side here, the left side, are the same 5. So it's only 5 droppers, it's not 10. And this is called a spot plate. This is what you would perform the reaction in. It's a little piece of plastic with, a certain number of little holes. Here's what we tend to use the clear in our labs. So, by the way, this page, every time you refresh it, the order changes, I believe. Let's see. The order is different now. Mine just means working alongside someone else, physically alongside, but if you're comparing what you get to someone else, just know it's not going to be necessarily the same. So what we want to do before you get started is scroll down the instructions here, and you see these letters X, G, W, Y, and B. Those are going to be like the codes that you're going to enter as your data. So my suggestion would be to take a little piece of paper and write those codes down, just because you're going to reference it a lot. Maybe take a picture with your phone. It just saves you a lot of clicking forward and back. Now, once you do that, I suggest you hit record your observation. And basically, the way this works is, right now they're labeled. You're going to perform this lab with all 25 reactions. And you're saying, hold on, it looks like there's more than 25 spots here. There are. This spot plate is larger than it needs to be. We're only going to need 25 of these. So you're going to perform all 25 of these reactions, and you're going to fill in this data sheet as you do it with your codes. X means no reaction. W means white precipitate, things like that. And then once you have that filled in, you're going to click on knowns, unknowns, and look what changes. The names go away. And it also shuffled the order up. So don't think it just cut it out and you can just remember. It randomized the order. What you're then going to do is re-perform the same thing with these 5 unknowns. So you're going to have this filled in, which are like the unknowns, and you're going to compare it to this, which are the knowns. So it's like you're solving a mystery using the data up front, and then when you click the known unknown, you can solve the mystery that way. All right, so anyway, you want to start out by having it known. And what we're going to do is put barium nitrate in all of these, potassium carbonate in all of these, Ki in all of these, and so on. This one, by the way, HNO3, that's hydrogen nitrate. That's commonly called nitric acid. Now, we didn't necessarily do naming acids yet, but that would be nitric acid. So the idea is, let's start by doing that. Let's fill down the line. So you click once to get us the barium nitrate, and once again on each spot, and you're filling these in like that. Now, this also works starting by going across. Either way is fine. All right, let me put that back and grab a second one. You just click on it once, and you click on the spot that you want to place, and another click puts the drop there. or you could just kind of double click and it goes quickly. Now notice I'm not actually doing the reactions yet. I'm not going spot by spot. You can if you want, but I prefer to get the starting ones down, and then all you need to do is add these horizontal ones and you'll see each reaction go through. All right, so here's my Ki. Here's my lead-2 nitrate. Here's my nitric acid. Okay, now notice nothing actually happened. We didn't see any reactions or anything. By the way, if you accidentally misplace one, this Q-tip tool will like clean any cell out. And if you totally mess up, you can hit that to clean all cells, or I guess you could just refresh a page and it'll totally restart it from scratch. So right now we have barium nitrate down here, potassium carbonate, potassium iodide, and so on. What we're now going to do is add our horizontal ones, and now we'll start seeing those reactions. Before we do, I just want to comment on one thing. Notice the white color behind this spot plate. This is assumed to be like a clear spot plate with a white background. It's tough to use a white background because most precipitates are white. Most ionic compounds, which that's all precipitates are, it's insoluble ionic compounds, they tend to be white. And just to have a white precipitate form against a white background, it's hard to see. So what we'll actually usually do in a lab is if you have a white background, you'll slide a piece of black paper behind it so you could see it better. Now, when we do this in Wilton, our lab tables are naturally black, so we don't even need that. But what you can do here is like slide a piece of black paper under it, and now you could see it better. You could just take it away and add it with this. All right, so I like leaving the black paper underneath, but you will have to pull this back and check from time to time, because if a black precipitate formed right now, you wouldn't be able to see it against the black background. But since most precipitates are white, it makes sense to keep this black background on. All right, so just as a reminder, the barium nitrate is here, potassium carbonate is here, and so on. Let's start adding our second set. All right, so I'm going to grab my barium nitrate and I'm going to now go across the line like this. Now you want to go one at a time and you want to make your observations now and record it in your data table. So the first thing I'm going to do is add that to that. Now you saw the drop go in, nothing really happened though. And that makes perfect sense because when you add barium nitrate to barium nitrate, you're not going to get anything. You're just adding more of the same. So this was to be expected. Now to record this in the data table, you can't click and edit this directly. So what you do is you hit the pencil. While this is pointed at that cell, the pencil will ask what you want in that cell. And it defaults to X, which according to our code means no reaction. And that's what we're going to write, X. Okay, let's add the next one. So now we're going to go across like this. We still have the barium nitrate and we click that and hey, look at that, white precipitate. Okay, and just to make sure there was no black precipitate in the first one, you can like clear the color and see that. So yes, we have a precipitate. We're going to hit our pencil. We're going to say W for white precipitate. Okay, next one. Looks like nothing. Let's just confirm. Okay, nothing. So we put an X. Next one. Looks like nothing. Yep, nothing formed. So we put another X. And for the last one, looks like nothing. Just checking. Yep, nothing. So we put another X. All right, and then you just continue. Notice it's filling in the data table as we go. Let me just pick one more row to do. Let me do this HNO3 one. Actually, I'll do the next one down the line. Potassium carbonate. All right, so you click here to put that back, and now I'm going to grab my K2CO3, and I'm going to now go across this way. All right, so for the first one, white precipitate. So we hit the pencil, we type a W. Next one, K2CO3. Now look, K2CO3, K2CO3, nothing's going to happen here. There we go, nothing. X. Next one, looks like nothing. Yep, nothing happened. Notice why it's important to have the black background. You can't see those white ones unless you have the black background. All right, the next one is K2CO3 plus PbNO3, white precipitate. Pencil W, okay. And the last one, now I believe something interesting is going to happen. Focus really closely on this one, right where my cursor is. All right, you see that? Okay, the Q-tip kind of spazzed out there, but that wasn't the point. The point was the bubbles. You saw the bubbles that formed there. And when you see bubbles, what is that a sign of? Gas. So we're going to hit this, and we're going to put a G for gas. And in fact, if you check your solubility table, you can figure out exactly why we saw a gas there, wherever it is. Oh, looks like I forgot to include one here. I want to go back and make sure I fix that. So I'm going to point back to this one, and I'm going to hit my pencil, and we saw no react. There we go. So notice I have 2 of the rows filled in. I mean, this isn't going to take you more than a few minutes to fill this in like that. So let's say you fill the entire thing in. You now have your known reactions, okay? What we're now going to do is try to solve the mystery. So you hit knowns, unknowns, and at first you might freak out because it looks like all your hard work is gone, but it's not. All you need to do is hit this again, and it comes right back. But here's the thing. As I said before, it scrambles the order, and it makes it now unknown. So what you're going to do is the same thing. You're going to take dropper number 1 and go down the line. Dropper number 2, down the line. Or you could start by going across. Or you can do one cell at a time, doesn't matter. Dropper 3 down the line, and so on. All right, you get the idea. And now, once you have those done, we're going to go across. So number 1 here, probably no reaction, makes sense because number 1 added to number 1, nothing's going to change. So you hit this and you call it X for no reaction. Let's put it across here. Oh, I forgot I need my black background. I could have seen a reaction there. Oh, I did. So we saw white precipitate there, so we're going to put a W. All right, 1 and 3, let's see. Looks like nothing. Let's just make sure there's not a black precipitate. Yep, so there's an X for no reaction. 1 and 4 looks like nothing. So we put an X for no reaction. 1 and 5 looks like nothing. X for no reaction. And notice we're now filling this grid in here. Okay, let's just do one more row. Oh, it makes sense if 4 and 5 didn't react because I forgot to add chemicals 4 and 5. In fact, just so we're sure, let's do this. That's 4. See? So something did happen. We saw a yellow precipitate. All right. Now I don't need to go through the whole thing. You get the idea. You lay all 25 reactions out here, and eventually this data sheet will be totally filled in. And at this point, you can click between the known and unknown by hitting this button. So you'll have this unknown data sheet, this known data sheet, and now you solve the mystery. You just use a little bit of logic, a little bit of problem solving. Look for things like the yellow precipitate. Look for like what formed the yellow one each time, because it's rare. We only saw one, and try to use that. Look at the gas. Not too many of them form gases, so when the gas forms, figure it out. Try to look for which ones form the white, which ones form none. The idea is to try to work through it and solve the mystery of the droplets. Now, once you think you know what each one is, and let me clarify. Once you think you've identified dropper 1, 2, 3, 4, and 5, and keep in mind this randomizes it, so if someone else says they got it, don't just copy their sequence because it's not going to be the same. Once you think you got it, you go to check your results. And here's, so, let's say I'm pretty sure number 1 is potassium carbonate. I'm pretty sure number 2 is Ki. Number 3 is barium nitrate. Number 4 is nitric acid. And number 5 is lead 2 nitrate. You go check results. And nope, I'm all wrong. And obviously, you don't want to repeat this if you get them wrong. I mean, there shouldn't really be any guessing here. You should work it out and know your answer. Now, once you're satisfied with your score, and this will be graded partially on their accuracy here. I'm not just going to say, oh, you got all 5, you get 100%. But if you don't get all 5 right, you're not going to get full credit. You're welcome to repeat this until you get it right. And then once you're happy with your score, if you get all 5, you click prepare for print. And here's where this screenshot's going to occur. You put your name and pop-up blocked. Okay, make sure you allow this pop-up to occur. Okay, let's try this again. Prepare for print. This is Joe Minor. All right, now notice what this shows. This shows me 3 things. It shows me your known scorecard, your data sheet filled in. It shows me your unknown filled in. This tells me you didn't just guess until you got the answer right. So I want to see this filled in correctly. I want to see this filled in correctly. And then this shows me how you did with your final check. So I want to make sure your name is here. Your sheet is filled in, and filled in here. And all you're going to do is you can even like save this, I guess, as a picture somehow, maybe not. you probably do like print and then save as PDF, or screenshot this, or even if you want to take a picture with your cell phone, just make sure it's super clear enough for us to distinguish all the data. And that is what you're going to post on Classroom into one of those assignments. So this is like, did you get it right? Let's talk about the follow-up work. So you'll notice on your scorecard here from the, how do I get to this? Record your observations. This shows you which reactions took place and which didn't. Now, no reaction is X. Every other one did react. Most of them are white precipitates, but when you see a gas, that still counts as a reaction that occurred. Or if you see a yellow precipitate, that still counts as a reaction. So what you're going to do is pick any 3 reactions that went through, and we want to see the total and the net ionic equation. Now, you have to type this carefully. It takes a while to type superscripts and subscripts in Google, but it is possible we want to see that done correctly. So let's look at the first one. Let me just grab this one. So this one's going to be barium nitrate and potassium carbonate. So assignment, you'll open up a new document. I'm just going to do it here for the sake of time. We have barium nitrate. Now, what I don't want to see is this. Okay? Take your time with it. To do subscripts in Google Docs, you do Control or Command if you're using a Mac, and it's the comma. That makes it small. So you go like this. Now, it's a solution. So what do I write? Aqueous. Okay? Now we make it big again. We go plus K2CO3. So I make it small here. K2, large CO3. Aqueous. Yeah, it comes out all nice, exactly how we want it. To do the yields, you go dash, dash, and then the sideways caret thing there, and it automatically calls that an arrow for you. And, well, you might be saying, how do I know which one was a precipitate? How do I know which one was aqueous? Great question. And, of course, this will tell you all the answers you need. And if you lost your copy of this, go to Google Classroom, scroll down the stream. I think it was February 19th. I posted this. It's a yellow document. You'll see it. So the barium carbonate, I'm pretty sure that's a precipitate here. The potassium nitrate, I know that that's not the precipitate because I know that all nitrates and all potassiums are always aqueous. So you're going to write out, actually, I'm setting this up wrong. I need to write the total and the net ionic equation. So you will balance it first and then do the total ionic equation and the net ionic equation. And remember, total and net ionic equations, when you have your your ions need to have charges. To do charges, like barium, you do command period or control period, and that gives you a superscript. So this, I'm going to say 2+, and then I'm going to bring it all the way down for subscript and call it aqueous. So that's my barium plus my 2 nitrate, so it's NO3 minus aqueous. See, it takes a while, but you got to do this very correctly. Now, I'm doing this before I balanced it. It's possible that you'll end up with coefficients here. Actually, I'm pretty sure in this case it won't. But basically, you want to take your time with this. So write out the full total ionic equation and the net ionic equation. Actually, it's a good idea to just include the balanced equation first as well. Okay, so that explains this assignment. Let us know. Your teachers will be online during your scheduled class periods. Let us know if you guys have any questions about this. But just take your time, and good luck.